Section 2.1 introduced us to the idea of what a set is. It's a collection of elements. So for instance, if I have a set A that looks like this, then I could pull out some of those elements and make another set. Let's call it set B. If I do this, then I can say that set B is a subset of set A. And that's what section 2.2 is talking about. Let's take a look. Section 2.2 is all about subsets. We're going to look at these three objectives, but we're not going to worry about this one. A good place to start is with the definition of a subset. Notice the definition says set A is a subset of set B if every element of A is also an element of B. Was that true of the very first example I showed you? Yes, it was. Take a look at set B. It's got C, D, and G in it. Is every element of set B also in set A? The answer is yes. So I can say that B is a subset of A. And I would write it like shown here. Notice the symbol. Let's take a look at the examples. Part A of example 1. Look at set A, look at set B. We're trying to figure out if A is a subset of B or not. So the question to ask is every element in set A also in set B? Yes. So here's what we do. I say A is a subset of B. Let's go on. In part B, we're saying, is every letter in the word proof also in the word roof? The answer is no. So A is not a subset of B. Look at C. Set A is a set so that every element in there is a planet of Earth's solar system. Then look at set B. It's using the roster method to list all of the planets in Earth's solar system. So is every element of A also included in set B? The answer is yes. So I can say that set A is a subset of set B. Okay, so far so good. But you know math can't just leave it at that. It's always got to add something else. So let's take a look at what a proper subset is. Again, let's start with the definition. I like mine a little better than what the book has. For A to be a proper subset of B, two things have to be true. First of all, A has to be a subset of B. And second, there has to be at least one element in set B that's not in set A. So in the example above, is B a proper subset of A? Let's take a look and see if these things are true. Is B a subset of A? Well, yeah, we already said that it was. Is there at least one element in set A that's not in set B? Yeah, there's several. So we could say that B is a proper subset of A. Here's how I'd write it. Notice it's slightly different from what was in red up above. This first notation says X is a subset of Y. The second one says X is a proper subset of Y. Well, what's the difference? Let's look at sets X and Y in the first case here. They both have the same elements. X is a subset of Y because everything that's in X is also in Y. But in this second case, set X has 1 and 2 in it, Y has 1, 2, 3, 4. Is set X a subset of set Y? Yes, because everything in X is in Y. Is X a proper subset of Y? Well, yeah, because both of those things are true. X is a subset of Y, and there's at least one element in Y that's not in X. There's the difference. Let's take a look at example 2 down at the bottom of the page. We're going to be saying is a subset of, or is a proper subset of, or both. Part A says set A is a person who lives in San Francisco. Set B is a person that lives in California. Is A a subset of B? The answer is yes, because every person who lives in San Francisco also lives in California. Now we want to find out if A is a proper subset of B. Take a look. We already know that A is a subset of B, so the first condition is true. But are there some things in B that aren't in A? And the answer is yes, there's millions of them. For instance, people that live in Los Angeles or people that live in Sacramento, they don't live in San Francisco. So I can say that A is a proper subset of B. Now contrast that with part B. Is A a subset of B? The answer is yes, because everything that's in A is also in B. So I write that down. Is A a proper subset of B? In other words, is there something in B that's not in A? And the answer is no. So I can't say that A is a proper subset of B. Take a look at this great question. Make sure you see the difference between the symbol for element of and the symbol for subset of. The element of says, is this one thing contained in a set? The subset notation says, is the whole set contained in another set? Don't get them confused. Taking a look at example 3, we just add a little bit to what we've been talking about. Over here on the left, I can write the empty set two different ways. Those both mean the same thing. Is A a subset of B? In other words, is the empty set a subset of B? And we go back to the definitions. Is there anything in A that's not in B? And since there's nothing in A, we can't say that there's something in A that's not in B. In other words, it's not like A contains the number 10 or something. A doesn't contain anything. So we can say A is a subset of B just by the definition. And I would write it like that. Is A a proper subset of B? Well, we know A is a subset of B, and does B contain things that are not in A? The answer is yes. It contains 1, 2, 3, 4, 5. So I can say that A is also a proper subset of B. And I'd write it like that. Notice something, whether we're talking about the empty set or not, that for one set to be a proper subset of another, it had to be a subset first. That's true in all of these examples. The last objective that we're looking at is how many subsets does a set have? So let's take a look at set M here. It's only got two elements, A and B. How many subsets does it have? Well, first, any set is a subset of itself, so there's one. And then just the element A is a subset of M. That means the set B is a subset of M. What are we forgetting? Oh yeah, the empty set, because the empty set is a subset of any set also. Now the question is, how many proper subsets does set M have? Remember, to be a proper subset of M, there has to be something in M that's not in the subset. Definitely true for that one. Definitely true for that one. Definitely true for that one. But here, everything that's in the set containing A and B is also in M. So there's 3 proper subsets, 4 subsets in all. So let's take a look at set Q. It's got the letters A, B, C, D in it. How many subsets? And the answer is a bunch. I made a list of these things, and I've got to admit it took me a while because right at first I was missing a couple. But notice, you might want to pause the video, and when you do, notice each one of these is a distinct subset of set Q. There's no repeats in there. All of these are different. So how many proper subsets? As we saw before, the only one of these that's not a proper subset is this one because it contains all the elements of set Q. It is a subset, but not a proper subset. In general, if I want to find out how many subsets there are, do I have to list all of them, or is there an easier way? As it turns out, there's an easier way. You just count how many elements there are in the set and raise 2 to that power. So with set M, it has 2 elements. That means 2 to the second power, I should have 4 subsets. And that means I can take 1 away from that and have 3 proper subsets. And with set Q, it has 4 elements, so I can say 2 to the 4th power equals 16. And I can take 1 away from, that's how many total subsets there are. I can take 1 away from there and I get 15 proper subsets. And that will work on any sets. So if we look at our final example here, example 4, part A, how many elements? There's 5. So I can say 2 to the 5th power gives me 32 subsets and 31 proper subsets. Part B says we want an x that's an element of the natural numbers, and x has to be between 9 and 15. How many elements? There's 9, 10, 11, 12, 13, 14, 15. That's 7 elements. 2 to the 7th gives me 128 subsets and 127 proper subsets. And that wraps up section 2.2. Let me know if you got some questions.